I have once again entered the mighty book of legend and returned with the fourth sheet on AQA GCSE physics. Advanced forces, which is basically forces part 2. So let's start with mass. Mass is not a force. It has the same value everywhere. It's scalar, which means it has no direction. It is measured in kilograms. It's the amount of matter in the object. It doesn't change anywhere because it's not affected by other forces because it isn't a force. So something to do with mass. The centre of mass is where the mass of an object is concentrated. So basically you can test this by seeing which place faces down at suspended equilibrium. So then you have to draw lines from where it goes down to and then you'll find it. So for example in this square rectangle it's there in the middle. But it could be more complex with more complex shapes, especially 3D ones. So gravity. So gravity won't pull if a stronger gravitational force is present. Basically connects all things through mass of the force. So everything has gravity, but we don't necessarily feel it because the gravity of the Earth is so strong on us that nothing else's gravity actually affects us. So yeah, Earth's gravity is 10 newtons a kilogram, which is quite a lot. So weight is linked to mass and gravity. Weight is a vector and it has different values in different places. Weight is a force caused by gravity acting on mass. You can use this equation here for it. Weight equals mass times gravity, Wmg. So mass is in kilograms, gravity is in newtons a kilogram. So basically weight is mass with gravity applied onto it, which means it's times together. So let's move on to elasticity. So elasticity is the ability of an object to stretch and change shape. It is governed by Hooke's law. Basically shows that the extension is directly proportional to the force applied. And the equation for this F equals K times E, where F is the force in newtons, K is a spring constant in newtons a meter, and E is the extension in meters. This is very similar to weight equals mass times gravity. As you can see, one of the things is something per something. So that's newtons per meter and that's newtons per kilogram. So it's basically you're finding out that each one of those and each one of those equals however many of these. So that is added on because that's the amount of that per that. So it's all linked together. So what is friction? So friction forces the road, is the force that the road exerts on tyres. So when something's stopping, which includes using friction, the stopping distance equals the thinking distance plus the braking distance. The thinking distance is the distance a car travels before the brakes are applied, and the braking distance is the distance travelled whilst braking. Basically the thinking distance is how long you spend before pressing the brakes, so how long you were thinking about pressing the brakes but didn't, and then the braking distance is the amount of distance that actually travels whilst it's braking, as it slows down incredibly quickly when you hit the brakes. And now we move on to the legend himself, Issac Newton, Apple Man. Yep, the almighty Apple Man. So, he came up with 3 laws. Newton's first law was that a body will remain at rest or continue to move with constant velocity. Forces acting on it are balanced. So basically, balanced forces is where you got the same amount of newtons of force acting on it on the different sides. So say it was acting 4 newtons left, 4 newtons right, so it's 4 newtons that way and 4 newtons that way, it would cancel out to 0. And if it reaches 0, it will either stop if it's already stopped, or it will continue to move if it's already going at a constant speed, because it's staying at the same speed because the speed isn't going up or down until something changes it and it's no longer balanced. So, Newton's second law shows us that acceleration and force are directly proportional, which means they both go in the same direction. So one goes up, the other goes up, one goes down, the other goes down. Same with current and voltage, I believe. So yeah, force equals mass times acceleration. So the force something exerts equals its mass, how heavy it is. Remember, mass is without the effects of gravity, time acceleration, which is how fast it's going. So the force something has is its mass, which is basically its weight without gravity, times how fast it's going. We can remember this as if something's going faster, it exerts more of a force, and if something's heavier, it also exerts more of a force. So therefore the force would rise. So Newton's third law, when body A exerts a force on body B exerts an equal and opposite force on body A. So basically this means if something applies a force on something, the other thing applies a force back. An equal and opposite force. So this is basically to do with the conservation of energy. So energy can't be destroyed, it can only be converted to other types of energy, which means that this energy is released somehow and will be exerted in an equal and opposite force. Sometimes that is like a physical force, like actual recoil, or sometimes it just goes down to the environment. So now we get onto the complicated thing, momentum. So all moving objects have momentum. You might not need all this stuff. This is higher stuff, higher GCSE obviously. So momentum is a measure of how hard it is to stop a moving object. So this equation, MMV. So momentum in kilograms meters a second equals mass in kilograms times velocity meters a second. You can remember this as the kilograms and the meters a second go together to make kg meters a second, as you can put together. So when a force is applied, momentum is changed. So this delta symbol basically means the change in. Delta is D in the Greek alphabet, if you wanted to know. Pretty sure gamma's also in that, and lots of other things, alpha, beta, testing. Momentum, the P here stands for momentum, so it's a change in momentum equals force times time. So you can figure out the change in momentum if you know the force that something's applying and how long it's applied it for. This makes sense as you can see how long the force is acting over the time, and that makes the momentum decrease. As the forces are working against the momentum, it should go down as it becomes less hard to stop the object, because it slows down because the forces are acting against it. So basically, by figuring that out over the time, you can figure out how the momentum is changing per second. So that was Advanced Forces Part 2. That was fun, I guess. So yeah, Phys for Advanced Forces. Goodbye.